Hey, how's it going? So, on today's show, for the first time in the history of the show, the illustrious 1 year, 23-ish episode, 200 or so viewers. Okay, it's not that big of a deal. I'm doing organic for the first time. Here's a little fun fact about organic. Once upon a time, the definition of organic was things that were only made by living systems. But what happened was that chemists got so good at making things in the lab that they were soon able to make things that used to only be made by living systems. But a side note, trivia, the first of these compounds was urea. So they had to change the definition to things that were based on the element carbon. Then about the mid-90s, a bunch of hippies took the word from us and changed it to mean bullshit marketing tactic to overinflate the price of grocery products. And that was a sad day in the history of chemistry when we lost organic to hippies. I mean, how bad do you have to suck to lose a fight to a hippie? They're hippies. I mean, remember when Occupy Wall Street and the Arab Spring thing was happening about the same time? Do you think those Wall Street guys were ever worried about being dragged out into the streets and beaten to death like Gaddafi? No, because they were dealing with fucking hippies. Here's another fun fact. Wall Street brokers used to, during the whole Occupy movement, they would walk around with hacky sacks in their pockets, kind of like postmen with dog biscuits. So if they were ever confronted with a hippie, hey man, you're doing bad things making money, man. That's not right. That was my Tommy Chong impression. But hey, man, the Wall Street guys could just pull a hacky sack out of their pocket and go, hey, go get it, boy. Hey, there you go. Yeah. So anyway, why don't we short Amazon on? Now, I do have to say, grass-fed beef is really good. It's not all bad, I guess. But anyway, organic chemistry. So the first thing I thought we'd talk about, we'd cover would be alkyl halides. That seemed a sort of good first one to talk about because that's usually the part in organic one where students start to feel a tinge of pressure or a sense that they might actually have to study. Or they just won't be able to get away with rote memorization. Kind of like back in General 1, when you hit around, I guess, the mole and stoichiometry, you got that sense of, oh man, I'm not going to be able to memorize my way through this course. Or also, you think back to General 2, there was a sense early on, probably around kinetics, maybe solutions, where you realize that there was some stuff that back in General that you probably shouldn't have forgot, but you did. That tends to happen around the alkyl halide part of organic 1. So first off, if you're struggling with alkyl halides or just general things about mechanisms, you should go back and cover not only mechanisms, but probably polarity and probably formal charges back in your old General 1 or General Chemistry book. And if you still don't have your Gen Chem book, might I suggest, I really hope I remember to go back and put in my book. Anyway, so you probably know alkyl halides, they have the general formula Rx, where R, you should know by now, is an organic chemist's favorite way to symbolize organic stuff. And X is a common symbol for halogens. So usually you're taught initially that a common way to make these alkyl halides is to start with an alcohol, which are also introduced in this chapter or close to it, reacting an alcohol with a hydrogen halide, aka an acid. And when you do that, you can get an alkyl halide and water. So notice that this reaction isn't a completely new type of reaction. I mean, in organic maybe, but if you remember, go back and look at your Gen Chem book, when we talked about double displacements, which we did a lot around the solutions chapter, that chapter right after stoichiometry. This is really just a double displacement reaction. So you got your alcohol, the R, and the hydroxyl group, your hydrogen and your halogen. Yeah, they just do a swap. But instead of it being a pair of ions like you saw back in Gen Chem, it was some organic stuff, some nonmetals. Especially once you kind of see that water is HOH. That hydrogen swap took that to make water. So the mechanism for this reaction is one of the first organic mechanisms that organic students will probably encounter. And when you go over or when you learn this mechanism, there's some things that you can kind of pay attention to that'll really help down the road when you learn other mechanisms, and it'll really cut down on some of the rote memorization that a lot of organic students will feel pressured to do, especially the night before an exam. If you're watching this the night before an exam. But to start with, we're going to draw the alcohol a little differently than I did before for reasons that will hopefully become apparent later. For right now, the R is going to mean some organic stuff, or it can mean a hydrogen. But when it reacts with the alkyl halide, recall from General 2 when you talked about polarity that this alcohol is bent at the oxygen. So the molecule is polar, and the partially negative end of the alcohol is at oxygen, because this is basically water with one of the hydrogens sub for some organic crap. So you have your partially negative charge here, or with the hydrogen halide, there's a partially positive charge at hydrogen, because the halogen is more electronegative. It's pulling the electrons away from it. So the oxygen end of your alcohol, that's the nucleophilic part of your alcohol. And the hydrogen end of your hydrogen halide is electrophilic. So all electrophile and nucleophile, all those mean it's just an extension of the partially positive, partially negative stuff you learned back in General 2. A nucleophile is basically some partially negative part of the compound that's seeking the partially positive end of another molecule, your electrophile. So in this case, oxygen is going to share some of its electrons with that hydrogen, which is going to ditch that bond with hydrogen, or the halide, and that will give you this compound that is sometimes referred to generically as an alkyl oxonium ion. And you'll encounter these in other mechanisms as well. And a lot of similar things are going to happen. And when you pop that HX bond, you end up with your halide. So from this point, what happens next depends on what type of alcohol you have, whether it's primary, secondary, or tertiary. So remember, a primary alcohol is one where one of the things attached to the carbon that's attached to the alcohol group is some organic group. If it's tertiary, two of them are. Or not tertiary, secondary, excuse me. If it's tertiary, that's three. So if you have a secondary or tertiary alcohol, and I'll just use tertiary for an example. Oops. Whoop. Get back there, pen. Thank you. What happens at this point is that carbon-oxygen bond is going to break to give you a species we call a carbocation and water, which is a really common sort of thing you see in mechanisms. You see this alkoxyonium ion form and water will pop off. Again, very common theme or meme in organic chemistry. I was trying to think of a meme to make a joke about, but I'm blanking. Who's the dude with the hat? Doesn't matter. He'll be long gone by the time this video actually airs, probably. That was so 2000 late. But going back, all right. So carbocation. So this is step 2, the formation of the carbocation. And this step is your rate determining step. From there, your carbocation is going to hook up with that halide that popped off back in step 1. And you're going to form your alkyl halide. So that's why these types of reactions are referred to as SN1 reactions. Right. The SN stands for nucleophilic substitution, and the 1 comes from the fact that the rate determining step, step 2 here, is first order or unimolecular. One reactant decomposing, which again is a term that was introduced way back in General 2. So those are secondary and tertiary alcohols. If you have a primary alcohol, or this is also true for methanol, instead of the carbocation forming and then the substitution happening as a separate step, both of those things are going to occur simultaneously. So you have your alkyl ion. And your halide, it's going to attach itself to the carbon as the carbon-oxygen bond is breaking to give you your, I guess I should have gone and made that a primary, but that's okay. Whoops, that's not okay though. X. And there's your water. So again, instead of the 2 happening in separate steps, they're basically happening simultaneously. The halide attaches as the water is leaving. And that's why these types of reactions are referred to as SN2 reactions. Again, it's a nucleophilic substitution. There's your nucleophile substituting. And this time it's the 2 means it's second order, because in the rate determining step, which this is, there are 2 reactants involved. There's the halide and the alkyl ion. So it's 2 reactants, or bimolecular, if you remember that term from Gen Chem. So like I said, there's some things in this mechanism that you're going to see quite a bit as you move on to more mechanisms and other reactions. One, you're going to see the electrophile-nucleophile interaction happen quite a bit. So the easier you can spot the electrophile and nucleophile between 2 reactants, the easier it's going to help make figuring out the mechanism. And also too, if you can start to recognize, oh yeah, there's that alkyl ion, so probably a water is going to pop off somewhere. And other sort of similar recurring themes that happen in a lot of these different organic mechanisms. The more it becomes you sort of thinking through a problem, and the less of it's going to be you just trying to rote memorize your way through, the 2 or 3 chapters you need for the test. Person who's watching this the night before your exam. This is what we in the teaching industry call a teachable moment, assuming you don't do this again next time, but I talked about that in other videos. And I babbled enough about hippies. So a couple other things that we'll go ahead and cover. First off, I wanted to go back and say a little bit about why, yes, I have notes. You think I'm just doing this off the cuff? No. Because I forget stuff, like talking about why there are two different types of mechanisms. Well, it has to do with the fact that, those secondary and tertiary carbocations, those are a lot more stable than primary alcohol carbocations or a CH3 ion. I mean, those rarely exist in nature. And it has to do with this thing called the inductive effect. Because what happens with secondary and tertiary alcohols is that when you form that carbocation, the carbons, the adjacent carbons, they're able to supply some electron density to that positive carbon to kind of stabilize it a bit. That doesn't happen a lot with primary and secondary, or primary and alcohols and methanol. They're just too unstable that water's not going to be able to pop off until that halide comes in, and then it can pop off and form your products. All right, but a couple other ways you can make alkyl halides are what we call halogenating agents. And the two you run into the most in Organic 1 is this one compound called thionyl chloride and phosphorus trihalides, usually trichloride or bromides. So the way it works is, should have wrote it this way to start. Right. Those can react with your alcohol, and it helps if it's in the presence of a base, usually triethylamine or pyridine, which pyridine looks a little something like this. That will usually give you your alkyl halide. So we'll go over the mechanism of one of these. I guess we'll go ahead and do both just for the sake of time, because I keep hearing that, if you make these things longer than 10 minutes, nobody's going to watch. And a lot of people aren't watching, so maybe that's true. But I like to babble when we start. But anyway, we'll look at the mechanism between the alcohol and the thionyl chloride. So, as before, there's your nucleophilic part of your alcohol, your oxygen. Over on thionyl chloride, actually, here's a lone pair there, yeah. The electrophilic part is that partially positive sulfur in the middle. So, just like before, the electrophilic part of one reactant is going to be attracted to the nucleophilic part of another. And just like before, the nucleophile is going to throw a set of electrons its way. And usually some bond is broken, something pops off of the electrophile. In this case, it's a chlorine. And that'll give you this guy here. So I'll draw it this way. And there's your halide, kind of like before. So what happens next? Whoops, left off the water, didn't I? There we go. Yeah. What happens next is this is where the base comes into play. What the base will do is we'll use triethylene. Right. It'll remove that hydrogen. To give you this species. And from there, that chloride that was removed, kind of like our previous reaction, it's gonna come back around and attach itself to carbon. You're gonna lose that oxygen. Actually, I guess the electrons go here. And also another chlorine gets broken. And that gives you your alkyl halide, a chloride in this case. And your side products are sulfur dioxide and chloride ion. And you might wonder, well, there's a negative charge. Where's the positive thing? It's the organic ammonium that we formed here. So, like I say, you see a lot of the same sort of recurring themes or bits happening again and again when you start to look at these different mechanisms. And the sooner you sort of recognize them, the easier those later mechanisms you're going to encounter are going to get. All right. And just like with general chem, one thing I pounded the ground, literally, not figuratively, and try to, get general chem students to realize is that you can't memorize your way through gen chem. Right? There's too much math, if anything. You can't memorize your way through a math problem. And when students get into organic, they think that's not true anymore. And it may be a little more true than it was back in gen chem, but again, just trying to rote memorize your way through Organic 1, or God forbid both semesters, really isn't going to be the best way to go. Unless, again, this is the night before. Hey, night before guy or gal. Hope you don't cram next time. This is probably exam 1. I mean, really, you're off to a bad start. But, semesters are marathons, not sprints. Just hang in there. But for everybody else that's hopefully watching this, maybe a week before, I don't know when your cutoff point of your exam is. The more you start to recognize, like, again, some of the things you keep seeing over and over again, especially the nucleophile electrophile thing, that makes thinking your way through the mechanisms a whole lot easier. Because for the remainder of organic, 1 and 2 really, what tends to happen is you get introduced to a different compound or 1 or 2 class of compounds at a time, and they teach you how to name it, they teach you how to make it, they teach you some reactions that happen. And for those last 2, a lot of times they will go through the mechanisms, because understanding the mechanisms is a big part of understanding how organic reactions work. But that'll be it for this week. I don't know when I'm going to do organic again, but if you're an organic student, I don't know, check out some other videos, and maybe that'll help you shake off some rust that you may have. So that'll be it for this time, this week, this day, this hour, 15 minutes, whatever. Bye. And when you first start looking at this mech, damn it.